Hi all, welcome to my channel Tech with SAS. In last few videos, we had discussed the monolithic architecture along with the microservice architecture, and we also basically saw the drawback and benefit of each of them. So whenever you want to basically migrate to microservices architecture from monolithic, it is a hard decision because in a business world, we don't want to jeopardize our application functionality uh, just because like we want to migrate to microservices. So before we make a decision, it is really important to evaluate our current status and whether it is going to be beneficial or not. So let's look into the various strategies which we should follow, or how can we analyze our existing application before we make a decision. So if you are looking to migrate to microservices, so what benefits you are looking? Although we have discussed these benefits and drawbacks in previous videos, but let's basically revise for a moment. So when you move to microservices, there is a great degree of separation of concerns. So in monolithic application, all the functionalities are part of a big code base. So basically, they are tightly coupled functionalities. But when we move into the microservices world, the functionalities are separate, so they can basically change as per requirement, and they will not impact each other while you are developing the functionalities. Second thing is that deployment are easy because normally in microservice architecture we use CI/CD pipelines, and when one functionality is changing, then that is only impacted. So it's not like that. Like in monolithic, if even a small change will require the basically deployment of all a whole application, whole big application. The microservices, it becomes a kind of separate from each other. And Monolithic is good for small teams. If you have a very small application where three, four developers are working in great coordination, then we are good. But sometimes when we have like big teams working together in different time zones and different locations, and they are like in tune of hundreds of developers. So at that time, it is very good when we have the microservice architecture, because if one developer is working on, suppose, the payment functionality, it is not going to impact the authorization functionality. So all functionalities can be worked at the same time because code base is different for each of them. One big advantage of microservice is that suppose you have a diversified group of developers. Some are good at Python, some are good at Mule, some are expert in Java. So they can develop the microservices as per their preferred language. So in monolithic, it's difficult. It's not possible, in fact, to use multiple technologies because the code base is same. But in microservices, you can develop the services in various technologies based on expertise and requirements. So next is scalability by service. So when you have a monolithic application, you can't scale by the functionalities. You have to scale whole application together. But in microservices, there's advantage that you can scale your application by functionalities. Suppose your payment service is having more traffic and you want to scale it, then you can scale very easily. You don't need to scale the full application. So this is a great benefit of microservices. And when we use the OpenShift, Docker, and Kubernetes, it is really very easy to scale our application. By in a few seconds. So okay, so next thing is like maintenance and modification are easy. So whenever you have a monolithic application, whenever there is some change in some module, it going to impact all the application because you have to do the unit testing for your change along as well as whatever the regression is required as well because it might be possible that without intention, you might have impacted somewhere in the code for other functionalities. So it is better. So whenever we modify or maintain the monolithic, it becomes challenge. But for microservices, each functionality is separate, and so it is very easy to modify it and maintain it because one change in one functionality will not going to be impact in other functionalities. So these are the few good point which you can consider when you are contemplating to move to microservices from Monolith. So let's see what are various strategies. Like suppose you want to go to microservices, but you want to basically be safe and don't want to basically do any adventure so that it might jeopardize your application altogether. So let's see a few strategies by which we can do the migration to microservices. So yeah, so now we will basically discuss like if you have a big application in monolith environment and you want to move to microservices. So first approach is to basically rewrite the whole monolith application to microservice. So whenever you have deep pockets and you can basically have the huge infrastructure to support it, you can write the whole microservices from monolith. And for that purpose, like how can we manage it in production or UAT? You can run both applications in parallel because ultimately the functionalities are same. So you can basically divert traffic using load balancer like 20%. You want to go to basically to microservices new application, then rest of 80% you can go to monolith. So as time passes and you have more confidence on your new microservice application, you can decrease the traffic from monolith and increase traffic to the microservices application. Eventually, the monolith will be the phased off, and you will have your microservices application up and running. But here the risk is that you have to be very careful in the backend database side because at the time when you are running both applications in parallel, at that time you have to make sure that the data is consistent in in the database. So that is going to be a challenge, along with the cost of running the both applications together, as well as when you basically have some changes like so maybe for some time you have to make it in both of the applications. Suppose there's some requirement coming from business side and you are not fully live on microservices, then you might have to keep both code base in sync so that there is no impact on the business functionality. And next approach is basically incremental approach. In this, what you can do that you can live with your monolith application, that is fine. Let's live with this. But whenever you have an opportunity to create new services, at that time, what you can do, rather than changing the monolith code, you can create new services. Those services can behave as microservices and they can be called from monolith application like a REST API based. So that way, what is going to happen, that critical debt, what you have is not going to increase. So maybe in future, if some other application also want to use these new services, they can easily use it because they are kind of independent from monolith application. So this approach is also good. So if you are not in a hurry to the monolithic to microservices architecture, then this is a very good approach to consider. So now we will talk about a few scenarios, like maybe because every situation of a project or application of company is different. So you need to evaluate your position, your application, and your conditions, and then you can decide what to do. So let's see a few scenarios, like which are common scenarios I will discuss here. Like for example, you have a like a big mouse application is very complex and hard to maintain. So maybe like when we start application, it might be small. Over the years, it's become very big and hard to maintain. And developers who are joining new in the company, might find it difficult to maintain the code, understand the code, because the code is commingled very hard. So at this scenario, like when code maintenance is difficult and also functionality is overlapping with other functionality, so you can consider to go to microservices, because it is going to speed up your development process also in future, along with the new developers who will join the team. They don't have to understand the whole application as a whole, so they can understand the bits and pieces of the application. So it is a good candidate to move to microservices. Second scenario, like, yeah, so suppose okay, at Christmas time or Diwali time, you have a few functionalities which need a lot of traffic, which is like having a lot of traffic, and you're serving it like at huge traffic. Then in monolith application, what you have to do, you have to basically scale the whole application, because resources are very constrained. It's difficult to scale whole application to beyond an extent. So, but when you have microservices, at that time, you can scale any particular functionality at very ease. So if you have a scaling concern and you want to scale up, scale down your application, then you can consider for the microservices. Then, like few applications, maybe like have the vendor code. Like suppose you have like huge vendor code. For example, suppose you have some application from Mule side or some other applications which have huge vendor product dependency, and you just have some wrappers around it. At that time, it's not advisable to go to the microservices, because the every feature application is not controlled by you. Maybe in future, vendor can change some interfaces, or maybe they can add or delete the functionalities. At that time, you will be in soup. So whenever you have a vendor code dependency, it is really, it is beneficial to stay in the current state. So it is not advisable to move to the microservices architecture. Now, like suppose your application is not very stable. It's like every week, every month, the business process is changing. So as we know that Monolith is difficult to maintain and change the code if you have frequent changes. At that time, it is better to move to microservices, because at that time you'll have flexibility to just change that particular functionality, not the whole application impact will be there. So it is a good candidate should be moved to the microservice architecture.